Okay, so for today, our discussion in MA02 College and Advanced Algebra is radicals. Okay, but before we proceed with the radicals, we need to recall the concept of the laws of exponent, and also we need to introduce uh, zero and negative exponents. Okay, previously we have the positive numbers as our exponent, but here we'll discuss about the zero and negative exponents. And aside from that, we'll have the fractional exponents and radicals. And then lastly, we'll have the operations on radical expressions. Okay, so what are our objectives for today? Okay, so our objectives for today is evaluate expressions with zero and negative exponent, convert power with rational exponents to radical form, evaluate and simplify radical expression, perform addition and subtraction of radicals, and perform multiplication and division of radicals. Or in short, we have the operations on radicals. Okay, so again, here it is. Evaluate expressions with zero and negative exponent. And then convert power with rational exponents to radical form. Evaluate and simplify radical expression. And then perform the operations in radicals. Okay, so before we proceed with the radicals, let's have the concept of the exponent first. Okay, so let's say we have here a raised to n is equal to b, wherein a is the base and n is the exponent and b is the power. Okay, so aside from the laws of exponents that we discussed about the product of powers, quotient of powers, power to a power, power to a product, and power of a quotient. And we'll introduce also the power of zero exponent and the power of negative integer exponent. So as we recall, when it comes to positive integer exponent, we have here a raised to n is equal to a times a times a times a and so on, depends on our exponent, on how many times we multiply it by itself. Okay, and then we have the power of zero exponent, which is a raised to zero is equal to one. Any number raised to zero is equal to one, except by zero. And then the power of negative integer exponent, a raised to negative n is equal to 1 over a raised to n. Okay, where again, a is not equal to 0. Okay, we have the restriction here. Okay, so now let's derive the form of the zero exponent and the negative integer exponent from the previous laws of exponents that we've discussed. Okay, so let's recall the product of power. So in product of powers, we have your a raised to m times a raised to n is equal to, here we add the exponents, a raised to m plus n. Now, so let's say we let m be equal to 0. Okay, therefore, we have your a raised to 0 times a raised to n, which is equal to a raised to 0 plus n. Okay, and a raised to 0 plus n is simply a raised to n. Okay, so we have here a raised to 0 times a raised to n is equal to a raised to n. So let's manipulate the right-hand side. Okay, wherein a raised to n, we can multiply it by 1 and we still preserve the equation. Okay, so let's say we have here a raised to 0 times a raised to n is equal to 1 times a raised to n. And then let's divide both sides by a raised to n. We'll have here a raised to 0 is equal to 1, which is our power of 0 exponent. Okay, so let's utilize this also in negative integer exponent. Okay, so let's recall the quotient of powers. So we have here a raised to m divided by a raised to n is equal to a raised to m minus n. Again, let's let m be equal to 0. Okay, so let m be equal to 0. So we'll have here a raised to 0 over a raised to n is equal to a raised to 0 minus n. Okay, and a raised to 0, as we all know, is the power of the 0 exponent, which is 1. right? And 0 minus n is negative n. Therefore, we have here the power of negative integer exponent, which is a raised to negative n is equal to 1 over a raised to n. Okay, so aside from this, actually, we can use it in the quotient of powers. Okay, so let's recall the quotient of the power of quotient rather. Okay, so we're in the power of quotient. We have there quantity a over b raised to m, and then we distribute the exponent m. So we have here a raised to m over b raised to m. Okay, so let's say we replace m by a negative integer, which is negative m. Okay, so a over b raised to negative m is equal to a raised to negative m over b raised to negative m. Okay, so using the previous law that we can say that we have here uh, a raised to negative m as 1 over a raised to m, and then b raised to negative m as b raised to m. Okay, so we have here b raised to m over a raised to m. Okay, so simply we have here quantity b over a raised to m, and that's it. So as you can see, uh, we have a over v, quantity a over b raised to negative m is equal to b over a. Okay, the reciprocal. Okay, raised to m. Now, let's have the illustration of the given laws, the power of zero exponent and the power of negative integer exponent. So let's start first with 3 raised to 0 is equal to 1. Okay, so again, we raise it by 0, the result still 1. Another example, we have here negative 3 raised to 0 is equal to negative 1. Okay, there's a difference between number 2 and number 3. Okay, so always remember, okay, we have the parenthesis so that we can have positive 1 as our result. Quantity negative 3 raised to 0. Okay, is different from negative 3 raised to 0 equals negative 1. Okay, so don't forget that. And then another example we have here the expression. Okay, rational expression here. Negative quantity x squared minus x plus 1 over y squared plus y minus 2 raised to 0. Okay, so as you can see here, as we simplify, it's just simply 1. Okay, and then times the negative 1. So we have here negative 1. Then another one, quantity, no, negative 3 raised to negative 1. So that's negative 1/3. Okay, that is negative 1/3. Another example, 1 over 5 raised to negative 2. So reverse process. Okay, so that's 5 squared and 5 squared is 25. And then another one, 3 times x raised to negative 3. As you can see here, we have negative exponent in x. So that's 3 over x cubed. And then y raised to 0, quantity y raised to 0 raised to negative 1. Okay, so as you can see here, we have the power to power. Okay, so all we need to do is to multiply the two exponent here. 0 times negative 1, that's 0. And y raised to 0 is equal to 1. Another example in item 9, quantity 2xy raised to negative 2 raised to negative 1. So here we apply the power to a product. We distribute that negative 1. Okay, so 2 raised to negative 1 times the quantity of x times x raised to negative 1 times y raised to positive 2. Okay, because negative 2 times negative 1, that's 2. Okay, so we have 1/2 times 1 over x times y squared, or simply y squared over 2 over y squared over 2 over 2x. And then another example, negative 5 x raised to 0. So x raised to 0, that's 1. Negative 5 times 1, that's negative 5. Quantity 2x raised to 0 minus 2x raised to 0. Okay, so as you can see here, quantity 2x raised to 0 is 1 and minus 2 times x raised to 0, which is 1. So that's 2. 1 minus 2, that's negative 1. And then lastly, we have here negative 1 raised to negative 1 minus 2 raised to negative 1. Okay, so apply again the power of negative integer exponent. That's negative 1 over 1 minus 1 half. And we have here negative 3 halves. Okay, that is negative 3 halves. Aside from this, let's apply this law. Quantity A over B raised to negative M is equal to quantity B over A raised to M. Okay, so we reciprocate. Okay, for instance, 3 over x, quantity 3 over x raised to negative 2. So reciprocate, so that's x over 3, quantity x over 3 squared, or simply x squared over 9. Then another example, quantity 4a over b raised to negative 3. Again, applying the law. So we have your b over 4a cube. Simply b cube over 64a cube. Another example, quantity negative 5y over 2x raised to negative 2. Okay, so applying the rule, we have here negative 2x over 5y squared, and then negative times negative, so that's positive. So distributing it, applying the laws of exponent, we have here 4x squared over 25y squared. Another example, quantity negative a squared over b raised to negative 3 raised to negative 3. Applying the rule, negative b raised to negative 3 over a squared. Okay, is equal to negative 1 cube b raised to negative 9 over a raised to 6 is equal to 1 over a raised to 6 b raised to 9. Okay. And then a raised to negative 1 minus b raised to negative 1 is equal to 1 over a minus 1 over b is equal to b minus a over ab. Okay. The next one, x raised to quantity x raised to negative 3 minus y raised to negative 3 raised to negative 1. And so that's 1 over x cubed minus 1 over y cubed raised to negative 1. So applying the rule, we'll have here x cubed y cubed all over y cubed minus x cubed. Okay. Now let's try to evaluate. Okay, so here, as you can see, negative 3 raised to negative 3 minus the quantity of negative 2 squared raised to negative 1 minus the quantity of 2 raised to negative 2 raised to 0. Okay, so as you can see here, applying the laws of exponent here, specifically the 0 exponent and negative exponent, we'll have here negative 1 over 3 cube minus the quantity of negative 4 raised to negative 1 minus the quantity of 2 raised to negative 2 times 0. Okay, so simplifying this, we'll have negative 1 over 27 minus 1 over negative 4 minus 2 raised to 0 because negative 2 times 0, that's 0. Okay, and 2 raised to 0, that's 1. And then we have here double negative, so that's positive 1/4, and then negative 1 over 27. Okay, and then we have here the LCD 27 times 4, or simply 108. So we'll have here negative 4 plus 27 minus the quantity of 27 times 4. Okay, and then simplifying this, we'll obtain negative 85 over 108. Okay, so as you can see here, all we need to consider is the loss of exponents, specifically the 0 exponent and the negative exponent. Another example, quantity 4a raised to negative a plus 3 raised to negative b times the quantity of 4 raised to negative a minus 3 raised to negative b. Okay, so as you observe here, we can use the FOIL method or we can have the distributive property. Okay, but also observing this, we can say that this is a special product. which is the difference of two squares. Right? This is a difference of two squares. So they have the same first term, the second term, and then look at the operation between them. That's positive, plus and minus. Okay, so simplifying that, that's quantity 4 raised to negative a squared minus the quantity of 3 minus raised to negative b squared. Okay, simplifying that, we obtain 4 raised to negative 2a minus 3 raised to negative 2b. Okay, but need to simplify this that we so that we don't have a negative exponent. So we have here the LC, we have here 1 over 4 raised to 2a minus 1 over 3 raised to 2b. And then finally for the LCD, we have here 4 raised to 2a 3 times 3 raised to 2b. Okay, so simplifying this, we'll obtain 3 raised to 2b minus 4 raised to 2a all over 4 raised to 2a times 3 raised to 2b. Okay, and then we have here the last one, quantity x raised to negative 1 plus y raised to negative 1 all over x raised to negative 1 y squared plus x squared y raised to negative 1 raised to negative 1. Okay, so applying again the laws of exponents, specifically the negative exponent, reciprocal. Let's reciprocate this. So x raised to negative 1 y squared plus x squared y raised to negative 1 all over x raised to negative 1 plus y raised to negative 1. Okay, and then we apply again the laws of exponent, the negative exponent. So 1 over x, y squared plus x squared times 1 over y all over 1 over x plus 1 over y. So we have here a complex fraction. Let's simplify, identify the LCD. Okay, so simplifying the numerator, we have here y squared over x squared over y. Okay, so simplifying that, we have the LCD of xy. So for the numerator, we have here y cubed plus x cubed over xy all over. In the denominator, we have here y plus x over xy. Okay, so again, let's apply in complex fraction. Let's divide the numerator and the denominator. So all we need to do is to reciprocate the divisor here. So we have here xy over y plus x. Okay, so y cubed plus x cubed over xy times xy over y plus x. Okay, so as you can see here, we can eliminate xy because they have the common term for the numerator and the numerator. So simply y cubed plus x cubed all over y plus x. Okay, but observe this. The numerator, okay, we have here the numerator as the sum of two cubes, right? We have the sum of two cubes. So we can simplify this. Let's factor, and that is y quantity y plus x times the quantity of y squared minus xy plus x squared over y plus x. Okay, so as you can see here, we can eliminate y plus x since they are common factor for the numerator and the denominator. So the final answer here is y squared minus xy plus x squared. Okay, so the next one here in our discussion is all about the radicals.